Hello everybody. Can you hear me? If I'm audible, please let me know. Okay, Dipankar. At the outset, I would like to ask once again, as usual, how is the quality of broadcast? Are you finding it good? The quality of broadcast? If it is okay, then I'll move ahead. So rate it, the quality of broadcast on the scale of 1 to 10. Anybody to say 1 to 10 on the scale of 1 to 10? How do you rate the broadcast? Okay. Let us move ahead. And it is very important to know how is your preparation going on. Preparation should be consistent. You should be very much particular towards solving the problems and strengthening your theoretical portion. So if I would like to know the ratings from 1 to 2 on the scale of 1 to 3, 1 to 3, if I would like to know how is the preparation going on, then you should rate. Okay. Well, this is Vishwajeet Poddar. I am associated with chemistry teaching for past 15 years and have trained more than several thousand students and helped them to clear JEE and NEET exams. My interests are in organic and physical chemistry, but as a whole I teach chemistry in an interdisciplinary manner. You'll find various chapters which are interdisciplinary in nature, and that is being handled much more carefully. I'm driven to use technology to end avoidable human sufferings. This technology is you can sitting at home, you can know about plenty of things, you can discuss also plenty of things. So let us go ahead about all those things. And here, as a part of our series of lessons that we are discussing, we are having the third lesson of hydrogen, and where we will be handling about hydrogen peroxide. It is really a very intensive kind of lecture where you will come to know about hydrogen peroxide. It is very important a compound from various point of view that we will be seeing in our lectures that follows. Okay. As usual, about our course, you should know we have 90 plus classes, convenient educational platform. We have the syllabus from NEET experts, flipped classroom method, doubt solving practices, and many more things that you get. This is how you get to know about our classes. You know about the theory, you come across plenty of study material, you can come across webinars, homework, and then homework check also you get. Okay. I would like to repeat, you should subscribe to this Altedemy program, and we are making our smart program. We have light program, smart program, and proficient program, but I will advocate for smart program where you get almost everything that Altedemy has to offer. You can get plenty of things out here, right? Okay, let us come to content part of hydrogen peroxide. As I told you in the beginning, hydrogen peroxide is a very important part of inorganic chemistry, where not only the reactions but also its uses, also the strength of H2o2 that you come across. These are handled. These need to be known about. Here, there is some small errors that you might be noticing, that H2O2 is concentrated in physical properties of H2O, not H2O2. It's not H2. Nowhere H2O is mentioned. It is H2O2. Hydrogen peroxide. The formula, the molecular formula for hydrogen peroxide is H2O2. Right? So you can see these are the things that we will be studying, or we will be looking at in our this video lecture. Physical properties of H2O2, structure of H2O2, disproportionation of H2O2, acidic nature of H2O2. Here, everywhere, this is H2O2, 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 acidic nature of H2O2, H2O2 with PBS, the reaction, various reactions we are having, and uses of H2O2, tests for H2O2, strength of H2O2. These are some of the things that we are having, and there are important questions on volume strength also. Okay, let us come to another aspect. Hydrogen peroxide. It was discovered by Thenard. We were discussing in our initial class who discovered hydrogen peroxide, what was the role of hydrogen peroxide. Hydrogen peroxide was discovered by Thenard, and by the action of sulfuric acid on barium peroxide. Here, I would like to let you know about three different types of oxygen that we have. The first one, we write O, 2 minus. This is called as oxides, right? Oxide. We have O2, 2 minus. This is called as peroxide. And again we have O2 minus. This is called as superoxide. With oxygen, you can form different kind of substances, oxides, peroxides and superoxide. Let us understand. Let us try to understand. Suppose we have to write the formula of sodium oxide. Suppose we are writing sodium oxide. How will we write sodium oxide? Na, it has a valency of +1. Oxide O2 minus. So the resultant formula, as we do normally, it will be Na2O. Na2O is the formula of sodium oxide. Similarly, if we have to write sodium peroxide, suppose we have to write sodium peroxide. Again, we do like this. Na has +1 and peroxide has O2 2 minus. Now let us try to understand how will we form the structure Na2O2. This is sodium peroxide. And at the same time, if we have to write sodium superoxide, we can accordingly write superoxide. Sodium superoxide, Na, it has +1. Superoxide, O2 minus 1. So we can form the structure as NaO2. Just look at these three compounds that we have formed. Right? Sodium, which was monovalent, oxide is Na2O, peroxide is Na2O2, and superoxide is NaO2. These compounds are very much different. When we are saying here that hydrogen peroxide, how Thenard formed, he used sulfuric acid in barium peroxide. If we have to write the structure of barium peroxide, we should know Ba, it has +2, and peroxide, it is O2 2 minus. So we can form the structure as BaO2, it is barium peroxide. I hope you will in a position to write whenever peroxide of any element is asked to be written, right? Barium peroxide. The formula for barium peroxide will be BaO2. Am I clear from this count? Okay. So it was Thenard basically, and who discovered hydrogen peroxide by the action of sulfuric acid on barium peroxide, right? Barium peroxide was used with sulfuric acid and then the result was taken. Now, hydrogen peroxide is formed in trace quantity in this process. Trace quantity means it's a small quantity by the action of sunlight on water containing dissolved oxygen. It occurs in traces in air, rain, snow, and some natural waters and juices of certain plants. Hydrogen peroxide is found at different places. In air also it is found. In rain to some quantity it is also found. In snow also you get some quantity of it. Some natural water also contains and juices of some plants also. Certain plants. This gives you hydrogen peroxide. Let us move ahead. Now, how hydrogen peroxide is prepared in the laboratory. Laboratory preparation method we are right now talking in our next slide. We are using two different methods. First that we are using, it is by sodium peroxide. Again, formula you can just write for sodium peroxide. The formula that you will be writing is Na2O2, as we did in earlier slide. Sodium peroxide. Here the formula has been written Na2O2. It was difficult for me to do this subscript or superscript type of things. That's why I could not do it. It is just giving you a picture thing. You should understand it is Na2O2 plus 2H2O. The water that we are taking out here is cold water. We should bear in mind. So sodium peroxide, when it is heated with water in cold water, we are adding a small amount of sodium peroxide to cold water, we get, here there is arrow, and we get NaOH and hydrogen peroxide. In place of cold water, cold dilute sulfuric acid, it is 20%, can be added to the calculated amount of sodium peroxide. This can also be done. Instead of cold water, we can have dilute sulfuric acid, and it has been done like this. Na2O2 plus H2SO4, we get Na2SO4 plus H2O2. This also it can be done. Most of the sodium sulfate separates out on cooling as crystals of Na2SO4.10H2O. Like what happens that here H2O2, when it will be formed, out of that Na2SO4 will be precipitated out, and we get a 30% solution of hydrogen peroxide containing a small amount of sodium sulfate is obtained. This is the laboratory method of preparation of hydrogen peroxide. In this laboratory method of preparation, we get 30% concentration of hydrogen peroxide. Right? Okay. Let us try to solve a question. How do we prepare? H2O2 is prepared in the laboratory when? First is MnO2 is added to dilute cold H2SO4. Barium peroxide is added to carbon dioxide bubbling through cold water. Lead peroxide is added to an acidified solution of KMnO4. And sodium peroxide is added with boiling water. Can you give me any idea how can we solve this? What will be the correct answer for this question? Anybody to answer? You will find that this is the correct answer. Barium peroxide is added to carbon dioxide bubbling through cold water. This is how we can get hydrogen peroxide that you will see in the later part of it. Look here. The question that we were discussing, it has been explained in the third part of it that you can just have. We deliberately gave this afterwards. Look here. It can be prepared by passing a current of carbon dioxide gas through a cold solution of barium peroxide in water. Barium carbonate, being insoluble, is filtered off. This is how we can prepare. This is one of the methods. This is known as Merck's method. MERCK''S. Merck's method. Merck's method. There are other methods also. The top one you can just have a look. It is from hydrated barium peroxide. Hydrated universal destination. This is option B. That's good. Very good. Very good. Option B is the correct answer that you said. Yes. Well, hydrated barium peroxide, you say. I mean, we use this. Hydrated means there is some amount of water added here. Hydrogen peroxide is prepared by adding barium peroxide to dilute sulfuric acid. This is 0 degrees centigrade. Anhydrous barium peroxide is not used. Anhydrous barium peroxide is not used. Remember it. Because barium sulfate forms a protective layer around unreacted barium peroxide. This is an important statement. And the question is asked like this in your NEET examination. Why anhydrous barium peroxide is not used? Because barium sulfate forms a protective layer around unreacted barium peroxide, which prevents the further chemical reaction. It is therefore always advised to use hydrated barium peroxide or aqueous barium peroxide, as we have taken out here. Arrow is here. Right? It is hydrated. Hydrated means there is some water of crystallization. Again, barium sulfate precipitate is removed by filtration, and the filtrate is hydrogen peroxide solution. Here you will get hydrogen peroxide solution. However, sulfuric acid acts as catalyst for the decomposition of hydrogen peroxide, and therefore the use of weak acids such as carbonic or phosphoric acid is preferred. Again, important statement. Instead of H2SO4, carbonic acid and or phosphoric acid. You know, carbonic acid is what? H2CO3. And phosphoric acid is what? H3PO4. Both these acids are weaker than H2SO4, that is sulfuric acid. This is preferred. Weaker acids are preferred here. And again, there is a reason. Right? Sulfuric acid acts as a catalyst for the decomposition of hydrogen peroxide. So if you will be using H2SO4, whatever H2O2 will be formed, it will start decomposing in the presence of H2SO4. But if we take H2CO3 or H3PO4, then the decomposition of H2O2 will not be there, and actually we require H2O2 in totality. Third one we discussed, it is a Merck process. It is dealt with separately, but at times it is asked. Again, let us come to another process of preparation of hydrogen peroxide. I told you, preparation method of hydrogen peroxide is very important. Hydrogen peroxide as a compound is very important. It has oxidizing nature, it has reducing nature, it is in acidic medium as well as in basic medium. It works like this. So that we will be seeing. But how do we go about the electrolytic process of manufacturing of hydrogen peroxide? Hydrogen peroxide is manufactured on a large scale by the electrolysis of 50% sulfuric acid followed by vacuum distillation. Vacuum distillation. This is again a term to be known about. Vacuum distillation. Vacuum, when we are creating vacuum means very low pressure, right? Low pressure. Why do we use this low pressure situation? Look, any liquid boils when its vapor pressure becomes equal to atmospheric pressure. So a liquid will start boiling as soon as its vapor pressure becomes equal to atmospheric pressure. So if we are lowering the pressure, external pressure, obviously we will help the liquid to boil at a lower temperature, and at times we require it. There are some compounds like H2O2. If we will keep on giving large amount of heat, it forms an explosive reaction. So instead of giving large amount of heat, we do low pressure, and it is called as vacuum distillation. We will be creating vacuum, or vacuum means we are creating low pressure, and on low pressure distillation is being done. This is equivalent to saying distillation at a low pressure. Vacuum distillation is almost equivalent to distillation at low pressure. Initially, ice cold 50% sulfuric acid is electrolyzed by using platinum anode and lead cathode. there are two different electrodes that we are using of platinum and lead. Anode and cathode are separated by porous stoneware diaphragm, and a current of high density is used for electrolysis. You know, electricity is passed for doing electrolysis, and we can conduct electrolysis to find out to create or to manufacture hydrogen peroxide. So a current of high density is used for electrolysis. At cathode, hydrogen gas is liberated. Look, H2SO4, when it is decomposed, here you should understand it is 2H plus 2HSO4 minus. These are the two things that we are getting. When we are decomposing H2SO4, we are getting 2H plus 2HSO4 minus. Reaction is balanced. Now, at anode, what happens? This 2 molecule of HSO4 minus, 2HSO4 minus, it results into a compound called as H2S2O8. H2S2O8. Can you let me know what is this H2S2O8? It is called as peroxydisulfuric acid. And this peroxydisulfuric acid, H2S2O8, it is distilled under reduced pressure, hydrolysis occurs, and distillate contains about 30% hydrogen peroxide. Look here. Suppose we have this H2S2O8. You put water out here. If we are putting H2O here, you can clearly see to it. We form H2SO4. 2H2SO4 plus H2O2. And now we can balance this reaction. Can we do it? So here we have 2 and 4 and 2, 6. So it is 2 here. So we can put here 2H2O. So now this way it will be balanced, right? So directly in H2S2O8, if we put water, we can get hydrogen peroxide as here we are getting here. It has been done in two different steps. Like here H2S2O8, water has been put. We get H2SO5 plus H2SO4, and H2SO5 plus H2O gives H2O2 plus H2SO4. If you will add these two reactions, you will get one and the same reaction here. You will get H2S2O8, and in H2S2O8 you put H2O, you get H2SO4 as well as H2O2. So this is another method of preparation of hydrogen peroxide with H2S2O8, peroxydisulfuric acid. Do you know what this acid is known as? What is the name of this acid? H2S2O8. I would like to let you know. Look here. We are making H2S2O8. It is this. I don't know whether you are aware or not, but then you should know. It is very important an acid. H2S2O8. This is the important part of this acid is there is a peroxide linkage in this acid, and it is time and again it has been asked in the examination. It is also known as Marshall's acid. Marshall's acid. Here the compound that you have formed, it is H2SO5. H2SO5 is again, look here, HOOS double bond O and H. H2SO5. This is known as Caro's acid. Caro's acid. These are two acids, Marshall's and Caro acids are as such which have peroxide linkage. And that is why their functioning and other things are different. We will be seeing it later. But you should know here both the things we have prepared, Marshall's and Caro's acid, in the process of preparation of hydrogen peroxide. I told you this is a intense lecture. There are a lot of concepts that you will be coming across which may be new to you. peroxydisulfuric acid, and I wrote it is peroxydisulfuric acid. I'm sorry, peroxy, not oxy will be written like this, OXY, peroxydisulfuric acid. It is I think it is workable, no issues. PEROXI disulfuric acid, it is fine as you have written. Okay, let us come to the auto oxidation process. This is again the recent process, very recent process of this is auto oxidation. In this process, what we are doing in auto oxidation process, hydrogen peroxide is prepared. Initially 2-ethyl anthraquinone. This is 2-ethyl anthraquinone. Quinone means there will be 2 double bonds here, and C2H5, this is ethyl, it will be here, and it is reduced to ethyl anthraquinone. Quinone to quinol has been formed. How has it been formed? By passing hydrogen in the presence of platinum, palladium or nickel as a catalyst. We have used them, and now we have this 2-ethyl anthraquinol. Quinol is OH that is attached with the ring, right? Now this 2-ethyl anthraquinol is oxidized by passing air, that means O2. Then hydrogen peroxide is formed along with 2-ethyl anthraquinone. Then anthraquinone, it is converted into ethyl anthraquinone, and then H2O2 is formed in this process. Hydrogen peroxide is extracted with water, and 2-ethyl anthraquinone is recycled. Again, it is recycled to form one and the same compound. The net reaction is a catalytic union of hydrogen and oxygen to yield hydrogen peroxide, and the yield is also very good. It is the latest process. Without committing any delay, subscribe us. Subscribe Altedemy, and we are committed for your purpose. So without wasting your time, do it. Okay. Well, the question that is asked in the format: hydrogen peroxide is manufactured by the auto oxidation of. Tell me, which will be the answer? Options are given here. 1, 2, 3, 4. 2-ethyl anthraquinone, anthraquinone, naphthalene, anthracene. Any answer for it? By the auto oxidation of. Option A, B, C, D. Anybody to answer? Hydrogen peroxide is manufactured by the auto oxidation of. The answer has to be chosen not from naphthalene and anthracene. It is an obvious, deleted choice. It has to be chosen from A and B, 2-ethyl anthraquinol or anthraquinone. Well, it should be 2-ethyl anthraquinone. Anthraquinone is fine, but there should be ethyl out here. Fine? Okay. Let us do the another slide that is called as concentration of hydrogen peroxide. How are we making hydrogen peroxide more concentrated? Because the methods that we are using, it is not giving hydrogen peroxide in a large concentration. So we can use some methods to concentrate hydrogen peroxide. Hydrogen peroxide obtained by the above method is always in the form of dilute aqueous solution. As you can see, we are finding dilute aqueous solution. Wherever H2O2 will be there, some amount of water will be there, or maximum concentration that we are getting, that is of 30% concentration. So concentration of this solution is difficult due to explosive decomposition nature of hydrogen peroxide. As I told you, we normally cannot concentrate hydrogen peroxide. The explosive decomposition is catalyzed by the presence of organic matter and metal ions. It is naturally present, so the hydrogen peroxide is concentrated by the following steps, and we can see the steps. What are those steps for concentration? Look here. These are the steps for concentration. Once we prepare hydrogen peroxide, it is very important to get 99 to 100% concentration of hydrogen peroxide. Let us try to work it out. Look at the dilute solution of hydrogen peroxide is carefully evaporated on water bath at 600 to 700 degrees centigrade. Water being more volatile than hydrogen peroxide, a considerable amount of water gets evaporated and the concentration of the solution becomes 30%. That concentration is 30%. Dimash, your answer is B. I suggested the answer is A. Let us check it out. Or it is ethyl anthraquinone. It's anthraquinone. Okay. Look here. Options are what? Options are anthraquinone. Anthraquinone is, if you do not put C2H5 here, if you do not put C2H5 here, it is anthraquinone. Anthraquinone. But we need a substance called as ethyl anthraquinone. We need a substance called as ethyl anthraquinone. Ethyl anthraquinone is necessary. You look here, there is a difference between anthraquinone and ethyl anthraquinone. It is fine. This anthraquinone can also be converted into ethyl anthraquinone, but if you take 2-ethyl anthraquinone, 2-ethyl anthraquinone is where you can just have a look. It is this 2-ethyl anthraquinone. If it is 2-ethyl anthraquinone, from here it can be solved. Please check it out. In my sense of understanding, it should be 2-ethyl anthraquinone. Right? Please check your answer. Okay. Come to another part of it. The above solution is distilled under a reduced pressure of about 15 mm water. Now, as I discussed about this property, distillation under reduced pressure, or we call this as vacuum distillation. Vacuum distillation. The above solution is distilled under reduced pressure of about 15 mm water, distills at first, and at 700 degrees centigrade H2O2 distills over. Repeated distillation gives 90% pure hydrogen peroxide. If we are doing repeated distillation, it is giving 90% pure hydrogen peroxide. Further concentration is achieved by cooling hydrogen peroxide solution with the mixture of dry ice and ether. And needle-shaped crystal of 100% pure hydrogen peroxide is separated out, right? So 100% pure hydrogen peroxide is separated by these 3 steps. If we follow it carefully, it will be done like this. Okay. Now, once we prepare hydrogen peroxide, the storage of hydrogen peroxide is also very important. And again, we have a question. H2O2 is stored in. And before we solve this question, just look at the theory that we have given you. Hydrogen peroxide solutions are stored in plastic or wax-lined glass bottles because contact with rough surface accelerates decomposition of hydrogen peroxide. So, answer becomes almost clear still. It should not be stored in glass vessels directly because alkali present in glass helps the decomposition of hydrogen peroxide. Small amounts of negative catalysts such as urea, glycerol, sodium stannate, acetanilide or sodium pyrophosphates are added as stabilizers. These are the terms that we are using: urea, glycerol, sodium stannate, acetanilide, sodium pyrophosphates. They are added as stabilizers. Dilute aqueous solution of H2O2 are fairly stable in acid medium or alcohol or ether. They are stable, and alkaline solutions are relatively unstable. Impurities like silica, MnO2, iron, manganese or alumina cause rapid decomposition. Now, H2O2 is stored in. Give me a rapid answer. Iron container after addition of a stabilizer, glass container after addition of a stabilizer, plastic container after addition of a stabilizer. Any answer? And none. Go ahead. The first statement is hydrogen peroxide solutions are stored in plastic or wax-lined glass bottles. Right? So plastic or wax-lined glass bottles. Glass container will not be a choice. So C will be a correct choice. It is plastic container after addition of a stabilizer. That's very right an answer. But you take a lot of time doing it. Anyway, thank you very much for being into the job. And about H2O2, this is the most important aspect. Strength of H2O2. Strength of H2O2. I would like to let you know a couple of things which is very important, and I need to write over it. My handwriting, you will have to bear with me. I have a poor handwriting, especially on the screen. Look here. We understand about molarity, we understand about normality. These are the ways to give concentration of various kind of solution. But regarding H2O2, the concentration of H2O2 is given in terms of volume strength. Volume strength. Like H2O2 is mentioned as we are saying 10 volume H2O2 or 20 volume H2O2 or 30 volume H2O2. H2O2 is written like this: 10 volume, 20 volume, 30 volume, like this. Why it is written and what exactly does it mean? We can understand it this way. If we take H2O2 and we decompose it, we can write down a reaction as H2O plus O2 and can balance it. It is 2H2O here, 2H2O2 here. Right? Now, if 1 milliliter of H2O2, which is not normally liquid, it can be gases also, but liquid H2O2, if it gives 20 milliliter of O2, then it will be called as 20 volume H2O2. If 1 milliliter of H2O2 gives 10 milliliter of O2, it will be called as 10 volume H2O2. So H2O2 is expressed, the concentration of H2O2 is expressed in these terms. And when volume strength is connected with molarity or normality, it can also be done like this. Volume strength can be written as 5.6 into normality or 11.2 into molarity volume strength. We will prove this later on, but as of now, to remember it, you can do it. How the volume strength can be connected with normality or molarity. We'll just see to it here. Look here. For example, 10 volumes or 20 volumes of H2O2, etc. We express it like this. These strengths signify that 1 volume of hydrogen peroxide sample on heating decomposes to give 10 volume or 20 volume of oxygen gas at STP respectively. Yes, I forgot to mention STP here. STP is standard temperature and pressure, and for your purpose, you will take STP and NTP to be one and the same unless and until it is specified. STP or NTP, they should be treated as equivalent for our purpose. And this means what? 1 atmospheric pressure and 0 degrees centigrade, that is 273 Kelvin temperature. Right, anyway. 10 volume or 20 volume solution of H2O2 give 200 milliliter of O2 gas at NTP. Will give O2 gas at NTP. Right. 1 liter of decomposition, 10 liter of O2 as to gas. Same thing, whatever I have mentioned, it should be understood it this way. right? We can convert it into molarity and normality, and you should remember the formula also. Look here. Hydrogen peroxide decomposes as per the equation. As we told you, the equation will be like this. 2H2O2 gives us H2O plus O2. 2 mole of H2O2 gives 1 mole of O2. So 1 mole of O2 is given by 68 gram of H2O2. Now we are calculating. Since 1 mole of O2 at STP occupies 22.4 liter, so we can say 22.4 liters of O2 gas at STP is given by 68 gram of H2O2. And from here we can find out then 10 liters of O2 gas at STP is given by 30.36 gram of H2O2. 10 liter of O2. Since percentage W by V refers to the weight of H2O2 in 100 milliliter solution, strength of H2O2 is 3.036% W by V. It requires a small correction. Yeah, Lima, you are absolutely right. We said answer is C. You can see it. If glass bottle has to be used, it should be lime. Otherwise, normally plastic bottle can be used to do it. You are absolutely right. Absolutely right. Let us come here. We are trying to solve this question. Like, suppose we have to find out. Here we are working out. Like we are taking, let us suppose 20 volume H2O2. Suppose there is a question 20 volume, and this is the most important type of question that you will come across. 20 volume H2O2. Find percentage W by V, find molarity, find normality. Suppose there are 3 questions like this. 20 volume H2O2. So we understand it like this. H2O2 decomposes H2O plus O2, and we can balance it 2H2, 2H2O2. The weight of this is 68 gram, and this is 22,400 milliliter at STP. As per this equation, we can understand this. Now, as per the definition of 20 volume, that means 1 milliliter of this H2O2 will give 20 milliliter of O2. Look here, we have two such situation and we have to fuse them. 68 gram, how have we come across 68 gram? The molecular mass of H2O2 is 68 gram, and this is 1 mole of O2, and the volume of 1 mole of O2 will be 22,400 milliliter at STP, that is 22.4 liter. And then as per the definition, 1 milliliter of H2O2 will give 20 milliliter of O2. This is as per 20 volume H2O2 definition. Now let us try to understand. If we equalize these two, look here, if we equalize these two, equalizing means what? We can write it like this: 20 milliliter O2 is coming from 1 milliliter, so 22,400 milliliter of O2 will be coming from 1 by 20 into 22400 milliliter of H2O2. Is it okay? You can cancel one this, and this is coming out to be 1120 milliliter. Is it okay? Now just try to understand. 68 gram H2O2 is giving 22,400 milliliter O2, and again 22,400 milliliter O2 is coming from 1120 milliliter of H2O2. Now this is same. Now we can use this percentage strength, percentage W by V. How do we find out? Weight of solute. We write it like this: weight of solute. Weight of solute is what? 68. Volume of solution. Volume of solution is what? 1120 milliliter into 100. This is how we can find out the percentage strength. Similarly, we can find out the molarity also. Molarity, weight of solute upon molar mass into 1000 upon volume of solution is 1120 milliliter. Normality also we can find it out. What will be the normality? Normality again we can write weight of solute upon equivalent of H2O2. Anybody can say what is the equivalent weight of H2O2? Molecular mass is 34. What will be the equivalent weight? It will be 17 into 1000 upon 1120. Or you can calculate it this way. You should try to abide by these instructions. You are given, this is the most important aspect. Even one question is asked from H2O2, it is most likely that it will be asked from the volume strength of H2O2. And volume strength, that means you will be given the volume strength of H2O2 and you will be expected to find out percentage strength or molarity or normality. Any of the three things. Either it can be found out this way or we have told you the formula also. With the formula also you can do it. If further things will be required, I'll clarify this. Okay, I'm slightly in a hurry. Okay, look here. Molarity of the solution is the number of moles of solute present in 1 liter of solution. Molarity of 10 volume of H2O2 is 0.893. Molarity of 10 volume of H2O2 is 0.893. How did we do it? I told you the formula. Formula goes like this. Directly you can apply the formula. Look here. Volume strength is equal to 11.2 into molarity. Suppose 10 volume strength has been given and you have to find out molarity. So you will write 10 is equal to 11.2 into m. M can be found out 10 upon 11.2 and it will be coming to be 0.893. As we have found out here, 0.893 m. Thank you, Manan. Thank you very much if you have understood it. But at the same time, you should remember this formula for quick things. Volume strength is equal to 11.2 into molarity. It can be done like this also. Look here. Here we have taken molarity of 10 volume of H2O2 is 0.893. How have we got this so quickly? The formula is volume strength is equal to 11.2 into molarity. For quick solving of the problems, you should remember this. It is volume strength, we have written 10 volume, 11.2 is the fixed value and it is m. For finding m, you can find it out. Suppose you have to find out the normality. Normality you have to find out. So again, the formula is volume strength is equal to 5.6 into normality. Suppose here 10 volume of H2O2 is equal to 5.6 multiplied by normality. So normality can be found out by 10 upon 5.6 and that is coming to be 1.786. I hope you will understand this clearly, right? So these are three quick methods to solve your problems of concentration on volume strength related to molarity and normality. Fine. Remember these two formulas for quick things because we will be giving you some more tougher problems where going by the details of it will be difficult for it. Okay, let us come to the physical properties of hydrogen peroxide. Okay, anhydrous hydrogen peroxide. Anhydrous means without water, is colorless syrupy liquid. In thick layers, it has a bluish tinge. It is miscible with water in all proportion and forms a hydrate. H2O2.H2O. It is more strongly hydrogen bonded compared to that of water. Remember it. If H2O2 is more strongly hydrogen bonded with water, and then if I ask you whose boiling point will be more, H2O2 or H2O? Naturally, more extended hydrogen bonding, H2O2, it will be generally having more. Like here, the estimated boiling point is 152 degrees centigrade. 152 degrees centigrade, estimated boiling point. and melting point is minus 0.4 degrees centigrade, right? It is 152 degrees centigrade. The zero has to be over, not 1520. There are, I'll try to rectify, because this particular program on which we are doing, the particular software that we are doing, this concept of superscript and subscript is slightly, either it is not there or I have not understood it, because this is slightly new to me. So it boils at 85 degrees centigrade under a pressure of 68 mm and forms prismatic crystals at minus 20 degrees centigrade. So melting point is this, estimated boiling point is 425 Kelvin, here 152 degree, 425 Kelvin. You should try to understand the figures also. 425, 273 you will be adding to 152, you will be getting 425. Vapor pressure at 298 Kelvin is 1.9. Density of solid at 268.5 Kelvin, it is 1.64. Density is more. Density or liquid at 294, it is 1.44. Viscosity is 1.25. Dielectric constant is 70.7. And electrical conductivity of this. Look here, when you are studying inorganic chemistry for various kind of liquid and such substances, the different physical properties that we have mentioned here. Look here, what are the physical properties that we have mentioned? Melting point, boiling point, vapor pressure, density, viscosity, dielectric constant, and electrical conductivity. These are some such physical quantities that are profusely asked in almost all the situations. So for all the liquids, if you are comparing or studying, make yourself familiar. You do not need to remember it. I mean, as if everything has to be in your memory, but then you should have a vague idea. Look here, join our Telegram group. You should do it as fast as possible for more of PDF material, more of free classes, more of announcement, more of discounts and prices and all those things you can get. Join it at fast, right? Okay, let us come to another portion. Chemical properties, very, very important, very important. In chemical reactions of H2O2, look here, I have mentioned these things here. The most important aspect. As I told you, it can work as an oxidant, oxidizing agent. It can work as a reducing agent also. And in both the mediums, acidic as well as alkaline medium. So, in a nutshell, when you are studying the reaction of hydrogen peroxide, these are 4 different types of reaction you should bear in mind. 4 different types of reaction. Look here, as oxidizing agent, as oxidant. Oxidizing agent itself gets reduced. You know that. Oxidizing agents are those substances which itself get reduced, which undergoes reduction. And reduction means what? Gain of electron. Look at these 2 reactions. Here electrons have been gained. H2O2, by gaining 2 electron along with H plus, if it is acidic medium, it forms H2. If it gains 2 electron, it can form OH minus in alkaline medium. Reduction potential for this is plus 1.77 volt. Reduction potential for this is 0.87 volt. As a reducing agent, the reducing agent itself gets oxidized. It undergoes oxidation, means loses electron. Look here, in all those reactions there is a loss of electron. Arrow is here. Electron is on the product side. So it acts this way. H2O2 loses H plus O2 and then electron is being lost. Again here also H2O2 plus 2H minus H2O plus O2. Here again electron will be there because here 2OH will be having 2 negative charge. Here you can add 2 electron. These are the 4 reactions which are of great importance. Chemical properties of hydrogen peroxide widely differ from those of water. Hydrogen peroxide can act as an oxidant as well as a reactant in both acidic and alkaline conditions. The oxidation state of oxygen in H2O2 is -1. Remember this, very important. H2O2 can therefore be oxidized to O2 where oxidation state is 0. In this process, H2O2 acts as a reductant. You should make yourself familiarize with the concept of oxidation, reduction, Oxidizing agent, reducing agent in terms of electron. Oxidation means loss of electron, reduction means gain of electron. The substance which is undergoing oxidation is a reducing agent. The substance which is undergoing reduction is an oxidizing agent. Okay, so it is like this. Hydrogen peroxide is a very powerful oxidizing agent, but a poor reducing agent. Very powerful oxidizing agent. Hydrogen peroxide acts as a good oxidizing agent in acidic medium than in basic medium due to greater standard electrode potential. So this reaction is the most important reaction for you. Okay, about the decomposition of H2O2, again they have a question. Decomposition of H2O2 is retarded by acetanilide, MnO2, zinc, finely divided metals. Can anybody say? We have discussed it in our earlier lecture. Anybody to say, suggest something? Look here. Alkaline solutions are relatively unstable. Look here. Decomposition, about decomposition we're talking. Impurities like silica, MnO2, iron, manganese or alumina cause rapid decomposition. Silica, MnO2, iron, manganese or alumina cause rapid decomposition. And here we are asking about the decomposition. And the question is, decomposition of H2O2 is retarded by? What answer you can give? Anybody to say? Decomposition of H2O2 is retarded. Okay, just think over this question and give me a proper answer to it. Okay, right? I'm moving it for the time being. Okay, let's talk about the oxidizing property. I'll be running short of time, so instead of doing it, I will explain you one last very important thing, which is regarding the structure of H2O2. Look here. This is the structure of H2O2. There were two persons who suggested the structure of H2O2. One person suggested that structure of H2O2 will be like this. This is King-jet structure. And there was another person who suggested it is Bayer's structure. Bayer suggested H2O2 like this. Both have their own logic, keeping in view the properties of hydrogen peroxide. And finally, if you see the development dipole moment values and X-ray study of the solid hydrogen peroxide indicates that the molecule has a non-planar and non-linear. It is called as an open book structure. H2O2, very peculiar, it is open book structure. Called as open book structure. Normally, if you ask for H2O2 structure, make an open book. Let us make an open book like this, and the book is like this. This is, I am telling about a normal H2O2. It is in the gas phase, it is in the solid phase. This angle normally for H2O2 when it is in the liquid phase, it is almost 94 degrees centigrade. And both the oxygen are lying here. And on one page here hydrogen, another page here hydrogen. And this angle is approximately 97 degrees. So there are two angles that need to be mentioned. 94 and 97 degrees. In gas phase, some changes occurs. This angle becomes 111.5 and this angle becomes around 94.8 or 95 degrees. In solid phase, this becomes 90.2 and this becomes 98.8. So some kind of different 101.9. I'm sorry, 90.2 and 101.9. There are two different kind of structure. and the two different structures have been suggested. The name of these two person, Kingjet and Bayer's structure, they are known as this. All right. It can be best pictured as two oxygen atoms lying on the spine of a book, open at an angle, and one hydrogen atom in each leaf as shown. So in general, if it is asked, how is the structure of H2O2? You will say H2O2 is open book structure. Now, further to that, it can be asked. Further to ask, it can be said like this: 94 degrees centigrade. You're asking 94. Look here. Suppose you have a book in your hand. Fine. Suppose you have a book in your hand. Right now, I do not have a book. Suppose you have a book in your hand. You can open both the pages of the book. I mean, let us say you are opening the book. Now, in both your hands, there will be two things. Now, if you open the book at an angle of 94 degrees centigrade, make it static. Now, imagine that this book is opened at an angle of 94 degrees centigrade. The two sides of the book are open at an angle of 94 degrees. 94, not 94 degrees centigrade. I'm sorry, this is not 94 degrees centigrade. It is 94 degree. I'm absolutely sorry. Not degree centigrade. 94 degree. It's nowhere centigrade. 94. This I inadvertently wrote. I'm sorry for this. 94 degree. So it is, the angle is 94 degree and this is 97 degree. These are the two angles that we mentioned. Right? Savio, 94 degrees centigrade. It was an inadvertent mistake. Okay. Thank you for correcting me. Thank you for correcting me. I know I'm sitting with intellectual people. So I'm very thankful to you that you are doing these kind of corrections. Okay. So such kind of structure we can say. So there are plenty of things that are there with H2O2, and I think I have covered almost a lot of things which are important, and rest of the things, if you feel like going through it, you can have different kind of slides here and can go through it and can solve a problem. In next lectures, we will be coming up with more of questions on this entire hydrogen chapter, and I hope that will serve your purpose. Thank you very much. Thank you very much for being with us, and I can take leave right now. Okay. Thank you everybody. Thank you everybody for joining, and thank you making a good feedback to me. Thank you Savio. Thank you Lima. Thank you Manan. Thank you everybody.